so this is the second half of the worksheet. If you want to look at problems from the first half, check out the other video. All right, so this one is interesting because we have logs on logs and powers and lots of things happening. So let's sort of do this in a couple different ways. So the first one I'm going to do is I'm going to look at, we have log base 5 of 5 to an exponent, right? This is the exponent of 5. And so our properties say that this is going to come down. So this is really log base 2 of 32 times log base 5 of 5. And so now we can simplify. Log base 5 of 5 is 1, right? That's one of our sort of properties we talked about, or our patterns, if you will. If we have log base b of b, it's always 1. So this is really just log base 2 of 32. And so we want to know 2 to what power is 32. And so we actually did that. Well, let's just redo it. So we got 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. And 2 to the fifth is 32. So this is just 5. Another way we could do this is we could just look at log base 5 of 5. This is a log 5 to the power. This is an exponential. They undo each other because they're inverses. So this whole thing cancels, but we're left with the log base 2 of 32, and that just takes us quickly to this line. Here, let's look at our next one. So this is very similar, except we have a power in a power. So there's a lot sort of going on here. So let's look first at just the exponent here. So we have log base 2 of 3 to the log base 3 of 5. So what we might think here is that we can bring this down, right? And we get log base 3 of 5 times log base 2 of 3, right? So if we do that, we're going to end up with, this was 4 to this exponent, and so now we have 4 to this exponent. So the problem here is that that doesn't necessarily let us do anything after that, right? This, I would say, is not particularly useful. So instead what we want to do is look at some of our sort of relationships we have here. The first relationship that we should see is we have 3 to the log base 3. So we have an exponent to a log, right? That's basically the equivalent of saying we have a power that we are taking the root of, right? Or that we have a plus 3 and then immediately a minus 3. And so our exponents undo each other. So when we take the exponent of a log with the same base, they're going to undo each other. And so these things effectively cancel. And so what we really have here is 5. And so we've got 4 to the log base 2 of 5. I would say this is one of the more trickier ones. And so if we wanted to do the same thing that we just did here, that would be great, right? The only problem is that 4 and 2 are, those bases are not the same. But if you remember back to an exercise we did earlier this unit, we want to maybe change them to be the same. And so we can change that 4, right? 4 is 2 squared. So I'm going to rewrite this. We had 4 log base 2 of 5. Well, 4 is really 2 squared. So I've really got 2 squared to log base 2 of 5. properties of exponents tell me that this is 2 to the 2 times log base 2 of 5. We might be tempted to cancel and just be like, all right, that's 5. But we can't do that because we have this 2 out here. We need to get this 2 back in. And our property says that if we have a coefficient, it becomes an exponent. And so this is 2 to the log base 2 of 5 squared. And so now we have 2 to the log base 2. These are going to cancel each other out. And we're going to end up with 5 squared or 25. So this one's definitely a little bit tricky. And we're really using here the fact that exponents and logs are inverses, or they undo each other, right? Let me see if I can explain that another way. Let's take a second and look at just this 3 to the log base 3 of 5. And then we're going to take a second and just look at log base 3 of 5. So log base 3 of 5 is equal to something, right? So let's replace this with that question mark. This is 3 to the something power, right? But what is that something? That something is the power of 3 that gives us 5, right? That's what our circle says. 3 to the power question mark equals 5. So that means that this, which is equal to this, is just 5. That's sort of why they cancel each other out. Our log tells us the exponent that gives us 5. Then we're putting that in the exponent of 3. So we're just going to get 5 back. Right. So if we look here, we've got e to the natural log of 2 to the log base 2 of 4 cubed. And so looking on the outside, we've got e to the natural log. Those are the same base. They're going to go away. Now we've got 2 to the log base 2 of 4 cubed. 2 to the log base 2, that's going to go away. So we've got 4 cubed, or 64. So the big thing we want to get out of this today is that bases and logs cancel each other in the same way that addition and subtraction cancel each other, in the same way that powers and roots cancel each other, and in the same way that division and multiplication cancel each other. They are inverse operations. All right, let's take a look at 13. So we've got log base 3 of 9. 1/9. So we could use our properties, or we could just say, all right, we know 1/9, that's going to be negative. So the question is log base 3 of 9. 3 to what power is 9? Well, that's 2. If we wanted to use our properties of exponents, let's revisit that one more time. We're going to have log base 3 of 1 minus log base 3 of 9. Log base 3 of 1 is 0, right? Because log base b of 1 is always 0. And then 3 to what power is 9? Well, that's 2, and so we get negative 2, right? This was just sort of our creative way of thinking about it after we looked at a bunch of logs. All right, number 14. So we know it's going to be negative because we're going to have that log base 64 of 1 minus log base 64 of 4. And so we've got 0 minus. How are 4 and 64 related? Well, 4 cubed is 64, but remember that is backwards from what we wanted, right? 64 to what power is 4? Remember backwards is 1 over 3, so this is going to be negative 1/3. And what this is really saying is the cube root. Let's take a second to look at this a little bit more in detail. 4 cubed is 64. If we want to undo this 3, right? One way to do this is to make this a 1, right? To undo. Well, if we do 1/3 power on both sides, power to a power we multiply. This is 4 to the 3 times 1/3. 3 times 1/3 is 1, so that's 4, equals 64 to the 1/3. All right, we got a couple more. Log base 3 of 1. Hopefully you can get this one quickly. It's 0, right? This is our log. Log base b of 1 is always going to be 0, right? 3 to what power gives us 1? It's 0. Number 16, natural log of 0. Hopefully you also got this one fast. This is undefined, right? Inside of log must be positive. All right, let's look at 17. So this is kind of interesting. The first thing I would do is rewrite that square root as a 1/2 power. So we've got log base 2 of 8 to the 1/2. Now we're going to take that power outside of our log, right? That's one of our properties of logs. So we have 1/2 log base 2 of 8. This property is one of the most, I would say, important properties of logs for us, is we want to get rid of powers inside of logs, especially when it's something like this, right? Because a 1/2 multiplication is much easier to deal with than a square root. All right, so the next thing we're going to do is ask this question: do we know 2 to what power is 8? And hopefully the answer is yes. We've seen it a couple of times now. We actually already did it in this video. We see here that 2 cubed is 8. And so we're just going to put that in. So this is 1/2 times 3, or 3 over 2. So 2 to the 3 halves is 8. Let's take a second and look at that in case we're not comfortable with sort of those rational exponents. 2 to the 3 over 2. What does that mean? So this top one gives us the power. This bottom number gives us the root. This is saying the square root of 2 cubed. And we don't need to write that 2. And 2 cubed is 8. So that's how we get the square root of 8. So these rational exponents are always power over root. So if you had like 7 to the 4/5, this would be the 5th root of 7 to the 4th. This is equivalent to saying the 5th root of 7 to the 4th power, because if we split this up, this is 4 times 1/5, which you could either write as 4 to the 1/5 to the 4th, or you could write it as 4 to the 4th to the 1/5. That's because multiplication is commutative. It doesn't matter if we write this as 4 times 1/5 or 1/5 times 4. You get the same answer. All right, so our last one, we've got log base 16 of 1 over root 2. So our 1 over, we should be comfortable now, is going to be negative, just to sort of reinforce that incessantly. That's because we've got log base 16 of 1 minus log base 16 of root 2. And right now we should be pretty comfortable with log base 16 of 1 is 0. So we've got, that's where that negative comes from. We're going to rewrite that root as a 1/2. So we got negative log base 16 of 2 to the 1/2. Then we're going to pull that 1/2 down. It's going to end up being negative because there's a negative in front already. And let's go ahead and pull this over so we've got more room. So we've got now negative 1/2 log base 16 of 2. So now we want to know we want to know 16 to what power is 2. We've got a big base and a small number, so maybe we can reverse it to make it easier. The reverse is going to be 1 over, right? So can we answer instead the question 2 to what power is 16? Well, we've done a lot with powers of 2, so let's check what we did earlier, and it's right here. So 2 to the 4th is 16. And so this is 4, so that means our reverse is going to be 1 over 4. And so if we put that in, we've got negative 1/2 times 1/4, and we're going to get negative 1/8. So hopefully we see how we can use some of our properties. I would say that of the ones on the sheet that are the most important to sort of try and understand how we did them is this one, just because it's a fairly common problem to ask with this minus inside of our log. And then I would say that sort of understanding how we did, especially 12 and 10, when we're sort of canceling those logs, we sort of want to understand that those logs and exponential bases are going to cancel like that.